Good morning, class. Welcome to the online classes for class 9 physics. In the previous classes, we are learning about the chapter gravitation, and that we have completed almost all the theory parts, and we were seeing about some numericals in the last class. So let's continue that part. In this, we will be seeing about some conceptual questions as well as some numericals. So after this, your chapter will be completed. So we will have a quick revision about the whole chapter in the next session, and after that, we will be going to the new chapter. And for the first time, we will be giving a revision so that we can go through the last two chapters which will be coming in your first term. Okay, so let's start the topic. This topics in the questions you can even see in your refresher books which you're having with you. So see the first question. State the universal law of gravitation. In the universal law of gravitation, what we have read, that gravitation is some force which every object in the universe attract each other, right? And the gravitation is that attractive force. We have learned this earlier also. But if it asks state the universal law of gravitation, then how will you be telling that every body that is present in the universe attracts every body with a force? And I told you that this force is directly proportional to the product of the masses. So you have to write that line, that force is directly proportional to the product of the masses and inversely proportional to the square of the distance between them, right? So from here we have told about the gravitational constant. So from there we can say that the universal law of gravitation tells us that every body in the universe attracts every other body present in the universe, but this body exerts force, and this force is directly proportional to the product of the masses and inversely proportional to the distance between them. If we take the masses as m1 m2, then it will be m1 into m2 upon r square, and if we take out this proportionality sign and changes it into equal sign, then the new constant will come, which is capital G, and this G is said to be the gravitation constant, that is universal gravitational constant. In the numericals also we have used, that is 6.67 10 to the power minus 11, right? So the next question, write the formula to find the magnitude of the gravitational force between the earth and the object on the surface of earth. Here it is asked find the magnitude of the gravitational force. What this means, magnitude, this means that it does not depend on the direction. That is the only value that is regarding the size, shape, or the value of the numerical value, you can say. So numerical value of the force. So to find that, we have only formula that force is directly proportional to the product of the masses and inversely proportional to the distance between them. So here you can see on the screen the formula that F is equals to G m1 m2 upon r square. Here I am saying about the two masses m1 and m2, but it is taken as capital and small m. So there is no issue. If you want to take any of the masses, you can take, which is comfortable for you, you can just accept it. And just because you are just assuming that letters, so you can assume any of the variables. So next question, what do you mean by free fall? I have told you that any body, when it is fall downward, that is vertically downward direction, and the only force acting on it should be the gravity, then it is said that the body is freely falling, or a freely falling body. So if an object is allowed to fall from a height towards the earth's gravity, and that the other force will be not acting on it, the only force acting on it will be the gravitational force, then the object is said to be freely falling body. Okay. Now the next question, what do you mean by the acceleration due to gravity? We know that whenever we throw an object vertically upwards, or we allow a body to drop downwards, then the velocity of the body changes, and we know that this varying velocity is said to be the acceleration. But the question is, what do you mean by the acceleration due to gravity? Means the gravity is allowing the body to change its velocity. So how it will happen? See, when we allow the body to throw upward direction, let us take an example that we are throwing a ball on the upward direction, vertically upward direction, then reaching to the highest point, after that the velocity will become 0, and now it will come back, and this comeback of the path, or the returning back path, it depends only on the gravity, because gravity allows the body to come down, and the gravity acting on it will allow the body to change its velocity, that is the acceleration. So, and otherwise, if we take an example that we are dropping a body from the terrace to the downwards, then the body will go very fast than the velocity which we have given it, because the initial velocity is 0, because we don't need any velocity to throw a ball downward, we just have to drop it out. So we will not give that much velocity to drop, but when we come it downwards, then the gravity allows it to change its velocity, and the velocity increases while it coming downwards. So we can say that the velocity of the body increases while coming to downwards, and this change in velocity is said to be the acceleration. And this change in velocity is due to the gravity, so we can say that the acceleration is due to the gravity. Now it is asked, what do you mean by the acceleration due to gravity? So you can tell this example. What is written here? See, when an object is dropped from some height, acceleration is produced in it, that is the velocity decreases or increases at a constant rate. The uniform acceleration produced in a body due to gravitational force of the earth is known as acceleration due to gravity. Okay, so you may have understood what this acceleration due to gravity is. It is denoted by the letter small g, and the value of g is 9.8 meter per second square because it is acceleration. So unit will also be similar to that of acceleration. So 9.8 meter per second square, but numerically sometimes it is used to be given as approx value of 10 meter per second square. So when it is given, you have to use 10, otherwise it is 9.8. Okay. And after that, the question is, what are the difference between the mass of an object and its weight? I have already told you what the mass is. It is the value of the quantity of the matter present inside a body, right? Whatever the quantity is present inside the body, it is the mass of that body. And if you talk about the weight, then it depends on the gravitation, whether the gravity is acting on it or not. So along with the mass, the gravity is taken into the consider in the weight. So weight is given as a mg. It is a kind of force, right? And that force which is accepted to the body, that is accepted by the earth. So this is the difference between the mass and the object. Mass cannot be 0, but weight can be 0 if the value of the g is 0. Weight is not constant because it can vary anywhere, because if the value of gravity varies, then the weight will also vary, and the mass is never be a constant, it is always constant. Now the next question, why is the weight on the object on the moon is 1/6 of the weight on the earth? This is clear that the mass and the radius of the moon are less than that of the earth. Okay, so gravity present on the moon will also be less than that of the earth. But we know that when we divide the radius and the mass of both the mass and the earth, and the ratio it gives is of 1/6. So we can say that the gravity acting on the moon is 1/6 time of that of earth. So we can say that the weight of the body will also change, because if the gravity is 1/6, then the weight will also be 1/6. So if we go to the moon, then we will feel that our body is weight will be decreased to 1/6. Okay, so what we can say that the gravity exerted by the moon is 1/6 times lesser than that of the exerted by the earth. So gravitational force of the moon, that of the earth, therefore the weight of an object is 1/6 time of the weight on the earth. Okay, got it? Now what do we mean by buoyancy? Here this buoyancy we will be saying in the previous classes also in 8th, but you will be learning about this in more way in class 11th also. So what this buoyancy is, just understand a simple example of it, that whenever you allow a body to immerse in the liquid, that when you allow the body to get into the liquid, then some force acts on it, because we have to keep force to enter it into the water. When it goes on the surface, we just have to put some force to enter into it, but after immersing it, that force is become less. So we can say that whenever we immerse a body into the liquid, then some force is acting on the upward direction. So we can say that whenever an object is immersed in a liquid, that may be partially or fully, then that body experiences a force which is acting in the upward, that is in the opposite direction. And this force that is exerted by the water on this body is said to be the buoyant force, or this is also said to be the upthrust. Thrust means the force and up means the upward direction force acting on the body, that too due to the liquid. So it is a tendency of a liquid to exert the force which in the upward direction on that object is placed to be buoyancy. So this buoyancy can be of liquids also, and it can be seen in the gases also. Okay, so let's see other numericals here. See the question, that gravitational force on the surface of moon is only 1/6 as strong as the gravitational force on the earth. Now we have already discussed that the gravity on the moon is 1/6 times that of the earth. So what is the weight in newtons of a 10 kg object on the moon and on the earth? Now we are taking or accepting any object that is 10 kg mass, and this object is allowed to kept on the moon as well as on the earth. So we have to find out the value, what is the weight's value, and we know that weight is a kind of force that mass of the body is acted upon by the gravity. So weight is given by mg, and we know that the gravity on the earth is 9.8, and on the moon that is 1/6 of the gravity on the earth, then it will be 1/6 into 9.8. So now we will see how we will be finding the value of the numerical. See, here it is written, we know that W is equals to mg, right? That is the weight is equals to mass into gravity. And we know that the weight of the earth, that is earth's gravity, is 1/6 of the earth. That is, weight on the moon will be 1/6 of the weight on the earth. And we know the earth's gravity value is 9.8, and the gravity of the moon will be 1.6 of 9.8. Okay, so just calculate the value. If the mass of the object is 10 kg, that is m is equals to 10 kg, g is 9.8, then we can say that the weight on the earth will be 9.8 into 10, that is m into g, that is 9.8 into 10, that is 98 upon 10 into 10. So 10 and 10 will be cancelled. So we can say that the object present on the earth will be, the weight will be 98 Newton. Since it is a kind of force, weight is, so we will write it as Newton. But now if you have to take out the value of that object's weight on the moon, so weight on the moon will also be mg, but 9.8 is g, but it is 1/6, so 9.8 into 6 by 10. If it cancel out, then it will be 2 into 3, 2 5s. If we multiply this 5 into 9.8, then it is 490, and if we divide it by 3, we know that 16 3s are 48, 1 remaining, then 3 3s are 9, 1 again, it will be 3. So it is 16.3 something, so we can write as 16.3 Newton. Got it? So the weight on the earth is, that is 1/6 times that in the moon. So moon's gravity is 1/6 that of the earth. So have we got this numerical? So see the next question, that a ball is thrown vertically upwards. Now see, whenever the body is vertically thrown upwards, then we have to throw it with some velocity. So there will be u, okay, and v will be 0, because on reaching vertically upward to some height, it will come back after its velocity gets 0. So it is 0. And u is given as that we are throwing a ball vertically upward with velocity 49 meters per second. So it is the value of u. And now it is asking what is the maximum height to which it reaches. Now we have three equations, and in that second and the third equation uses the height, that is h is equals to ut plus half gt square, and the third one v square is equals to u square plus 2ag, sorry, v square is equals to v square is equals to u square plus 2gh. So there we uses the g and h. So there are the two formulas, but here the time is not given, so we will be using the third equation of motion, that is v square is equals to u square plus 2gh, right? But here if the vertically upward direction, so g will be taken as negative, that is minus 9.8. Now we have to keep the values. For v it is 0, for u square that is 49 whole square plus 2gs, that is 2 into minus 9.8 into h. Now let this minus part be going on the left side, then it will be 2 into 9.8 h is equals to 49. Now this h is equals to 49 upon 2 into 98, and if we write this upon 10, then that 10 will come on the numerator. Okay, now 49 ones are 49, and this is 2, so it is 10 by 4 something, so we have to divide it. So we'll get the value into 49 upon 98 into 2, and that is 10. Okay, so 49 2s are 98, so it will be 490 upon 4, sorry, it is 490 upon 4, so 4 ones are 4, 4 2s are 8, again this remainder is 1, so 10, that will be 4 2s are 8 again, then 25, so it will be 122.5 meter, that is the height, that is it can reach to the maximum height of 1.2 122.5 meter, and then it will be coming back with the velocity of gravity. So that is 122.5 meter. Okay. So what is the next question? That find out the total time take the body to return to the surface of earth. So what is the time taken? It will be t. So you can use the first and the second equation. For the second equation there should be h, so you can use the h also, and if for our first equation then it will be v is equals to u plus at, that is gt. So again the g's value will be minus 9.8 into t, and u will be 49 and v will be 0. So 9.8 t is equals to 49. So t is equals to 49 into 10 upon 98, because we have released this decimal. So on replacing it, the 10 will go to the numerator. Now 49 2 is 98 and 2 cancel, it is 5. So t will be equals to 5 seconds. So time is 5 seconds. So we can say that the body take 5 seconds to reach back to the surface of the earth when it is thrown with the velocity of 49 meter per second. So understand how do we have to find out these values. So you can see that is 5 seconds, but again it is written that take return back to the surface of the earth. But so we have find out the value that whenever the body move it take 5 seconds, and when it come back it will take another 5 seconds. So to return back to the surface it will be 5 plus 5, that will be 10 seconds. So see the next question, that whenever the stone is released from the top of the tower, now the stone is released, so we can say that it is coming downwards, so it does not want any velocity. So initial velocity will be 0, and final velocity, whatever the velocity given in the question, it will be the velocity of v. So stone is released from the top of the tower of height, that is h is equals to 19.6, and g will be taken as positive, so plus 9.8, because it is coming downwards and gravity is also acting downward direction. Now we have to find out v. What is v? So what are the formulas using this, whether it is the third equation of motion or the second, but in second time is required, so here the time is not given, so we will be using the third equation of motion, that is v square is equals to u square plus 2gh, then v square is equals to u square plus 2gh. Now v square, that is v we have to find, u square it will be 0 plus 2 into 9.8 into 19.6. Now we know 2 into 9.8 will be 19.6. Again one 19.6 is there, so we can write it as 19.6 whole square. So v square is equals to 19.6 whole square. So on comparing, the velocity will be 19.6 meter per second. So the value of the final velocity will be 19.6 meter per second. Have you got this question? So if you have any doubts, you can just ask. Okay. We will be discussing more in the online classes if you want to. Now the last question, see. A stone is thrown vertically upward. Now again it is thrown vertically upward. So whenever the body is thrown vertically upward, the u is to be there and v will be 0. So we have already got the value that v is 0. And the vertically upward with the initial velocity 40 meter per second. So u is 40 meter per second. Okay. So taking g is equals to 10. So I already told you that if in the question it is given 10, then you have to take the value as 10. Now the next, write out the maximum height. So we are having the two values to find out the h. That is the first, it is the second equation or the third equation of motion. But in second the time is used, and in the third equation time is not used. So here we will be using the third equation of motion. V square is equals to u square plus 2gh. So for v it is 0, for u it is 40 square plus 2gh. Since it is vertically upward, so it is against the gravity, so it will be minus 10 into h. So minus 20h will go this side, so minus 20h is equals to 40 into 40. So h will be 40 into 40 upon 20. So 20 will be cancelled. So 40 into 20, it will be 80 meter. So h is equals to 80 meter. Okay. So what we can say, that whenever the stone is thrown upward after reaching the maximum height, that is at it will reach to maximum height by 80 meter, and then again it will come back to the earth. So question, the another one is also there, that what is the net displacement and the total distance of the stone when it falls back to the ground. So we can say that when it is going vertically upwards, so the value of the displacement will be positive, then when again it coming downwards, then it will be minus. So we can say that it moved upward direction with 80 meter, and then again it is coming back, so it will be minus 80, and displacement will be 80 minus 80, that is 0. So displacement is 0. And if we talk about the total distance, then what we can say, it is going upward or downward, it will does not depend on the direction. So it is the total distance will be 80 plus 80, it will be 160 meters. So the total distance covered by the stone in reaching the maximum height and returning back to the earth or the back to the ground is said to be 160 meter. So here we go to an end of the numericals for this chapter. So if you have any queries and if you want more numericals, you can ask me. We will be discussing more about this chapter, but before this we have to go through the revision of the first term. So in the next videos we will be seeing about the chapters, that is force and the laws of motion and the motion chapter. So in that we will be seeing some numericals and the concepts, so that we will be getting ready for the term 1. Okay, so thank you class.